Alright, so in this, it wants you to construct a box and whisker plot. So therefore, you're going to create a number line from ever your min to your max, and then you can put your dots above it, okay? So I'm looking at this, my smallest number seems to be 12, and my biggest number seems to be 23. So I'm going to do 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Perfect. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, 20, cross it off, 21, 14, 21, 21, 12, 18, 23, 20, 23, and 12. I like to go ahead and count all my things to make sure I have the same number of data points as I do dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm good there. My maximum's clear, it's 23. Oops. It's 23. And my minimum's clear, it's 12. Smallest point, biggest point. Now the rest of it, I'm probably just going to type in my calculator in order to figure it out. So I'm going to go right here to stat. I'm going to edit my list. Whoever's used this before, they have to clear it out. And I'm going to do 20, 21, 14, 21, 21, 12, 18, 23, 20, 23, and 12. Once again, I got 11 data points because it's asking for my 12th. Stat, calc, one variable stat, enter, enter, enter. Okay, I'm looking for Q1, the med, and Q3. So when I scroll down, Q1 is 14, the med is 20, Q3 is 21, the min matches our min, which is 12, and the max matches our max, which is 23. And now we're going to find the IQR, which is Q3 minus Q1. Q3 was 21, and Q1 is 14. So when I do 21 minus 14, I get the IQR to be 7. Okay, lower fence, that's going to be Q1 minus 1.5 times the IQR. So Q1 is 14 minus 1.5. We just found the IQR to be 7. I'm going to type all that in my calculator. 14 minus 1.5 times 7. I get 3.5. Same thing, Q3 is plus 1.5 times the IQR. Q3 was 21, and we're going to add it to 1.5 times the IQR of 7. So when I see this, 21 plus 1.5 times 7, and I'm going to get 31.5. Okay, now that I got 31.5, if I'm looking down here, it says, do you have any outliers? So therefore, are there any numbers smaller than 3.5? Nope. When we're looking at our number line, our smallest number is 12. Are there any numbers bigger than 31.5? Nope. Our biggest number is 23. So therefore, no. There are no numbers below 3.5 or the lower fence, or above 31.5 or the upper fence. Last question is the MAD. I personally am going to use my calculator for this. So once again, we still have all of our data points in. We need to have the MAD, or the mean, because remember MAD is mean, absolute value, or absolute deviation. So if we go to calc, we find out the mean is going to be 18.63636364. So it looks like they rounded it off. Probably going to say I'm going to round that to 18.64. Okay, just round it to the hundreds. So when I go back to my list, I'm going to go over here to second 0 to get the absolute value of 18.64, I believe, minus my list 1. Okay, so to get list 1, you do second list 1. Let me double check that mean? I completely forgot it just now. So the mean was 18.64, so we're right, okay? So second zero, absolute value of 18.64 minus my list 1. And there it is. So now I'm going to take the mean of that again. So we're going to calculate, but instead of list 1 this time, it's going to be list 2. So you got to press second 2 to get the list 2 up there. And the math's going to be about 3.37. So I'd put about, because we rounded, 3.37. And that's section number 1. Section number 2, the box and whisker plot describes the number of books per student a class checked out from the school library in 1 month. What percent of students checked out between 6 and 8? Well, 6 and 8 is right here as the box. And remember, each piece is 25% of the data. So that's 2 pieces. So 2 quarters or 50 cents or 50%. That's how I think about it. What percent checked out 6 or less? Well, that is right here to the left. So that's only 1/4 of the graph, so that would be 25%. What is the mean? Remember, box and whisker plot, it only shows us the min, Q1, the med, Q3, and the max. So it's actually not available. What is the median? It's right here at 7. Okay, how many students were surveyed? Once again, the directions doesn't say how many kids were surveyed. And we don't know anything else besides Q1, or min, Q1, med, Q3, and max. So once again, that is not available. Describe the distribution. I would say it's skewed right because it's stretched on the right or there's few on the right. And since it is skewed right, the best measure would be the median. And the best measure of spread would be the IQR. Okay? Because whenever it's skewed, you always want to pick the median because it stays in the middle. And you always want to pick the IQR because that's like the measure of the box right there. So it kind of fixes the whole what if outlier part. Determine if any outliers exist, and if so, calculate it. So remember, we have to calculate the lower fence, which is Q1 minus 1.5 times the IQR. And we have to calculate the upper fence, which is Q3 plus 1.5 times the IQR. Okay? Q1 is 6, so the lower fence is 6 minus 1.5 times the IQR is Q3 minus Q1, so 8 minus 6 is 2. Okay, when I type all that in my calculator, I get 6 minus 1.5 times 2, which gives me a positive 3. So the lower fence is equal to 3. The upper fence, we know that Q3 is 8, which is right here. And 1.5 times my IQR stayed the same. It's 2. 8 minus 6 is 2. So I put that in my calculator. 8 plus 1.5 times 2, and it gives me 11. So when I'm looking at this, I want to know, is there any numbers below the lower fence? Well, my smallest number is 4, so we're good on that side. And now I want to know, is there any numbers above my upper fence? So the biggest number is 14. 14 is bigger than 11, so there is at least one outlier above upper fence, which happens to be 11. We don't know how many, but we know there's at least one because our data goes past the upper fence. Our upper fence is like right here at 11. Okay, and 14 is bigger than 11. Okay, on the back, we're now talking about histograms. So how many trees are 75 feet tall? So 75 would technically be in this bin. However, remember, histograms are measuring continuous data. So we just know the things in here are between 75 and 80. We don't know what those actual data points are, so we can't answer that question. So it's not really available. How many trees are at least 80 feet or tall? 80 feet is in here, because remember, when you get to the fence, you got to jump it. So at least 80, there are 5 in this bin, and there are 2 in this bin. So I would say that a total of 5 plus 2 would be 7. This right here, 80 or taller, 85 or taller. Okay, at least means you're 80 or more. Because if I say I have at least $20 in my pocket, I could have $20, but I could also have more than $20. How many trees were measured? Well, we would need to count all the frequencies or the number of occurrences. So there is 3 in this bin, 3 in this bin, 8 in this bin, and 10 in that bin. So when we add them all up, 3 plus 3 plus 8 plus 10 plus 5 plus 2, we get 31. So there was a total of 31 measured in there. Okay, the next one, describe the distribution. The peak of the data is in the middle, so therefore I would say symmetric. The best measure of central tendency would have to be the mean, because the mean is for symmetric distributions. The best measure of spread would have to be the MAD. And the bend width, that's the vocabulary word for what's the bend width, or what's the interval in which it's covering. It's going from 60 to 65, but not including 65. So I would take either 5 feet, or I would even, if you want to get technical, you could say, you could actually give me the interval in which it goes from. But I would say 5 feet, or you could say, if you want to get fancy, you could say from 60 less than or equal to x is less than 65. But this is a great answer, 5 feet. Okay, you don't have to get all fancy if you're not comfortable using that, okay? Because that's technically only for the first bend. You would have to do that for all the bends. But I would understand what you're saying. How many trees are less than 70 feet tall? Okay, 70 feet tall is in this bend right here. So all the ones that are less than 70 is 3 plus 3, okay? Because this goes from 60 to 65, not including 65, 65 to 70, not including 70. So it'd be a total of 6 trees less than 50 feet tall. Okay? What is the best measure of center and the spread for the data? So you got 2 options here. You can either type it in and look at how the mean is compared to the median, or I personally like making a dot plot. The smallest number I see here is 9, and the biggest number I see here is 47. So I would go, I'd probably count by 5. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45. Counted by 5s just because, I mean, that's a pretty good amount of data that they're covering, okay? 46, be kind of like right here. I guess I should put 52. 13 would be about right here. 42 right there. 40 right here. 39 there. 41 there. 42 here. 43, 9, and 47. I would say there's few data on the left, so I would say this is a skewed left distribution. So therefore, if it's skewed, you want to pick the median. So I get rid of mean, and I get rid of mean, because that's the best measure of center. And then remember, median always goes with IQR. Okay, MAD would actually go with mean. So that's some good ones that you can eliminate tomorrow on it. Okay, if you also want to do this, you would find when you type in your calculator that the mean is to the left of the median by a pretty good difference. It's not very close together. That would be another way how you could tell, or less than. Which one, list the order in which the central tendency is affected. Central tendency is like your mean and median. So which one is most affected whenever an outlier is in, and that's the mean. Because the mean is the one that gets pushed to the left or pushed to the right whenever it's skewed left or skewed right. And the median is least affected, which is why we usually pick the median for the best measure of central tendency. Okay, number 6, which is the best estimate for the mean if the median is 3? So when we're looking at this right here, this is definitely a skewed right distribution. So I know skewed right means mean went to the right. So if I'm looking at this, the line that's to the right is right here, okay? I would know that the mean would need to be right here. It told me the median was 3. So this line right here would be the median, because if the mean's to the right, that leaves the median on the left. So I would want to pick a point to the right. A point to the right would be both 4 and 10, so we get rid of A and C. And realistically, I would probably say that it's to the right here. I'd probably say it's 4, okay? Because 10, that's a pretty big stretch. This one is skewed right, but it's not very dramatic. So I would pick just to the right here.